We're going to expand a plus b to the third power. We're going to take a plus b times a plus b times a plus b again. Now, normally we'd use the FOIL method or distributive property. Remember, the FOIL method and distributive property, those are the same things when you're multiplying two binomials. So we would take a plus b times a plus b. With that FOIL method or distributive property, you would get a squared plus 2ab plus b squared. And then you would distribute that a plus b through that, and then the final result would be a to the third plus 3a squared b plus 3ab squared plus b to the third. So there's a lot of steps to that, a lot of chances for making a mistake. There is an easier way. We're going to look at the expansion of a plus b to the n power for the first few values of n. First of all, we're going to look at a plus b to the 0 power. So if you take a plus b to the 0 power, any non-zero term to the 0 power is 1. The coefficient on that would be considered 1. Now if we look at a plus b to the first power, a plus b to the first would just be a plus b. The coefficients on that are 1 and 1. If we look at a plus b to the second power, a plus b squared, that is going to be a squared plus 2ab plus b squared. The coefficients on that are 1, 2, and 1. So you can see a triangle is being created there with those coefficients. Now that triangle is fairly important because that's called Pascal's triangle, but it would help you expand something like this. And you'll see how all this works in a little bit. If we take a plus b to the third power, we already did that up here. That is a to the third plus 3a squared b plus 3ab squared plus b to the third. The coefficients on that are 1, 3, 3, and 1. You might start to see a pattern developing there with that triangle. If we take a plus b to the fourth power, imagine doing that, taking a plus b by itself 4 times. A lot of steps, a lot of work to that. That's going to be a to the fourth plus 4a to the third b plus 6a squared b squared plus 4ab to the third plus b to the fourth. So the coefficients on that are 1, 4, 6, 4, and 1. And again, that triangle is going to have a pattern to it that's created. It's called Pascal's triangle. Pascal's triangle is a triangular array of numbers in which the first and last number of each row is 1. So if you look at each row, the first and last number of each row is 1. Each of the other numbers in the row is the sum of the two numbers above it. So if we look at these last two rows, on each of these last two rows, the first and last numbers are 1. And if we look at this last row in comparison with the first row, the first and last numbers are 1, but if you add the 1 and the 3, you get 4. And if you add the 3 and the 3, you would get 6. And then add the 3 and the 1, you get 4. So you can create that triangle. If we go up another row, if you add the 1 and the 2, you get 3. Add the 2 and the 1, you get 3. So you can see that you could create that triangle. In fact, we have 5 rows there. We could get the 6th row by putting a 1 and a 1 on each side and then adding these numbers, and that's what goes between the 1s. So if you add the 1 and the 4, you'd have a 5. 4 and 6 would be 10. 6 and 4 is 10. And 4 and 1 would be 5. And then a 1 on each end. So you can create each row of that triangle. Also notice the exponents. When we expand these out, notice what the exponents do. The exponent on the a starts off at a to the first, and then really it ends at a to the 0 power. It's not there, but there is an a to the 0 power. And then the b would start off at b to the 0 power, and end up at b to the first. That's if you're taking it to the first power. Now down here, if you start the a off to the second power, start off at a squared, then it goes a to the first, then it would be a to the 0 on the end, even though that's not written there. The b would start off to the 0 power and then work its way up to b to the first and b to the second. You might see it better here. The a starts off to the third power, so the exponent that you're taking that to, the a starts off to that power, a to the third, and then works its way down to a to the 0. So we have a squared, a to the first, and then this would be a to the 0. And then the b would start off in the opposite direction. B would start off to the 0 power, then work its way up to that b to the third. So b to the first, b to the second, and then b to the third. So all those patterns that you're seeing there are going to help you expand something like this. In fact, we're going to go bigger than this. We're going to end up with something like a plus b to the 8th power, a plus b to the 6th power, something like that. It's a lot easier using this triangle, and you'll learn how to use it in a little bit, than it is to multiply those out manually. So you can create Pascal's triangle on your own for this binomial expansion. If we're going to expand a binomial, it's going to be a lot easier using Pascal's triangle than it is to do it manually. So if you take a binomial to the 0 power, for example, x plus y to the 0 power, the result would be 1. The coefficient would be considered 1. If you take a binomial to the first power, such as x plus y to the first power, the coefficients on that, x plus y, would be 1 and 1. Then if you take a binomial to the second power, say x plus y to the second power, it'd be x squared plus 2xy plus y squared. The coefficients would be 1, 2, and 1. But as long as you get those first two rows, you start with a 1 on each side, you can get these other rows by just adding. So add the 1 and the 1, you get 2. So for the next row, we're going to have a 1 on each end, and then we're going to add the 1 and the 2, that's 3. Add the 2 and the 1, that's 3. So the next row is going to be 1, 3, 3, 1, as you see. Now for the next row, we have a 1 on each end. So if we put a 1 on each end and then add in between, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and then you have a 1 on the end. So 1, 4, 6, 4, 1. Just adding above, 1 and 3 is 4, 3 and 3 again is 6, 3 and 1 again is 4. So if you take a binomial to the fourth power, those are going to be the coefficients of the terms. If you take a binomial to the third power, those are going to be the coefficients of the terms. So a binomial to the fifth power it's going to have coefficients of 1, 5, 10, 10, 5, and 1. So you put a 1 on each end, and then you add above it, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, and 4 and 1 is 5. Those would be the coefficients of a binomial taken to the fifth power. So imagine taking a binomial and multiplying it by itself 5 times. It'd be a lot of work. It's a lot easier to put the coefficients down, and we'll get to the rest later. If you take a binomial to the sixth power, to get the coefficients, put a 1 on each end, and then you add above. 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, and then 5 and 1 is 6, with a 1 on each end. And finally, if you take a binomial to the seventh power, the coefficients would be 1, 7, 21, 35, 35, 21, 7, and 1. Put a 1 on each end, add the row above. 1 and 6 is 7, 6 and 15 makes 21, 15 and 20 make 35, 20 and 15 make 35, 15 and 6 make 21, and 6 and 1 make 7. Those would be the coefficients of a binomial taken to the seventh power. Going to use Pascal's triangle to expand a plus b to the sixth power. Now imagine how long that would take you. If you took a plus b and multiplied by itself 6 times, it would take you forever. Not only would it take you forever, you'd likely make a lot of mistakes in the process. So we're going to use Pascal's triangle. Now on this first one, I suggest you just watch the process. If you're taking notes, maybe start taking notes on the next one. So a plus b to the sixth power, here's how it goes. We're taking this to the sixth power. We're going to use the coefficients on row 6. So if you were doing this on paper, you'd want to space out those coefficients because we have to put the a's and b's in next. So you'd space out those coefficients across your paper, coefficients of 1, 6, 15, 20, 15, 6, and 1. So you would space those out because you need to leave room in order to put the a's and b's in. So next we would put the a in. And when you put the a in, you're going to start the a off to the sixth power and then work your way down to a to the 0 on those terms. And then you would go to the b, start the b off to the 0 power, and then work your way up to b to the sixth on the last term. So here's what it looks like. We're going to space out those coefficients of 1, 6, 15, 20, 15, 6, and 1. And those coefficients came from row 6 because we're taking this to the sixth power. Now by row 6, don't get confused. The very first row is row 0, and then row 6 to the sixth power are these coefficients that we're putting in. Then you start the a off, the first term of the binomial, you start that off to that power. So you start the a off to the sixth power, and then a to the fifth, a to the fourth, a to the third, a to the second, a to the first, and then the last term would have a to the 0. And then the second term of the binomial, b, you start that off in the opposite direction. So you start b off to the 0 power, and then b to the first, b to the second, b to the third, b to the fourth, b to the fifth, and b to the sixth. Now, a quick check of your exponents. This is a good way to check, make sure you have the right exponents. Each of these pairs of exponents should add up to 6. So on each pair of exponents, on the a's and b's, they should all add up to 6. So if you simplify this, anything to the 0 power you can get rid of. So b to the 0 is 1. The 1 out in front, the coefficient of 1, you can get rid of that. You don't need that. So really that first term is going to be a to the 6th. And then down here on the end, a to the 0, we don't need that. That's just 1. We don't need the 1 out in front because we already have the b to the 6th there. So the final product here is a to the 6th plus 6a to the 5th b. Notice I changed that b to the 1st to just be b. And then 15a to the 4th b squared, 20a to the 3rd b to the 3rd, 15a squared b to the 4th, 6a b to the 5th. I didn't put the exponent of 1 on. And then finally, b to the 6th. So that is the expansion of a plus b to the 6th power. Again, the process, space out your coefficients. So space out the coefficients from row 6 because we're taking this to the 6th power. And then put in your a's, start the a off to the 6th power, work your way down to a to the 0. And then put in the b's. Start the b off to the 0 power and work your way up to b to the 6th. So that is the final product. Again, if you did that manually by hand with the FOIL method or distributed property, that would take you forever. So imagine multiplying that by itself 6 times. I wouldn't want to do it. Use Pascal's triangle. We're going to use Pascal's triangle to expand x plus y to the 8th power. So we're going to the 8th power. You're going to want to be able to create this triangle on your own. Otherwise, you will have to expand that out by hand or manually, multiplying x plus y by itself 8 times. To create the triangle, real simple. You start with the 1 at the top. That's taking the binomial to the 0 power. Then the binomial to the 1st power would have coefficients of 1 and 1. And then you just add in between. You always have a 1 on the end, and you add the row above. 1 and 1 is 2. For that row 3, where we're taking it to the 3rd power, put a 1 on each end of the triangle, and then you add the numbers above. 1 and 2 make 3, 2 and 1 make 3. So you might want to practice making that triangle on your own. We're going to expand this to the 8th power. Notice we only have row 7, but we can create row 8. We're going to have a 1 on the ends, and then we're going to add in between the numbers above. So 1 and 7, that's going to be 8. And then 7 and 21, that'll be 28. 21 and 35, it's 56. 35 and 35, it's 70. 35 and 21 is 56. 21 and 7 is 28. 7 and 1 make 8, and you have that, again, 1 on the end. So those are the coefficients for a binomial expanded to the 8th power. So if we're doing this, we want to space out those coefficients. So we want to space out these coefficients for row 8, and then we're going to put the x's and y's in. So space those out across your paper, and then you put in the x's and y's. So you're going to start the x off, the first term of the binomial, to the 8th power, and then work your way down to x to the 0 power. So it'd be x to the 7th on the 2nd term, on the 3rd term be x to the 6th. So you're working your way down with the x's until you get to x to the 0. Then you start the y off, the 2nd term of the binomial, in the opposite direction. You start the y off to the 0 power, and then you work your way up, y to the 1st, y to the 2nd, y to the 3rd, all the way up to y to the 8th. Again, check your exponents. Make sure each pair of exponents always adds up to 8 on each term. That's so you can make sure you have the right exponents in place. So to finish this off, clean this up. We don't need a 1 out in front. We don't need y to the 0. So that first term is just going to be x to the 8th. And then for the 2nd term, we don't need y to the 1st. Just y is fine. So that's 8x to the 7th y for the 2nd term. The terms in the middle here, those pretty much stay as they are. When you get to the end, the last 2 terms, we don't need to write x to the 1st. Just x is fine. So that'd be 8x y to the 7th. And then on the last term, you don't need the 1. And you don't need x to the 0. Those are both 1. Just y to the 8th for the last term. So the final product would be this. Now again, respect the process of using Pascal's triangle versus the process of expanding that out manually. If you'd have to take x plus y by itself 8 times, you would be working on it for a very long time. This is the final product. The coefficients are all spaced out. X's and y's are in place. We got the right exponents. We're in good shape. That is the expansion of x plus y to the 8th power. We're going to use Pascal's triangle to expand x plus 2 to the 4th power. So a little bit smaller on the exponent than the last one, but now we have a number inside the parentheses along with that variable. No big deal. So x plus 2 to the 4th power, we want to look at row 4. Those are our coefficients that we're going to space out. Now I call that row 4, but it's actually the 5th row down from the top because the very first row is row 0. So when I speak of row 4, I'm talking about an exponent of 4, those coefficients, 1, 4, 6, 4, and 1. You want to space those out across your paper, 1, 4, 6, 4, and 1. Then we're going to put the x in. So we're going to start the x off to the 4th power on that first term. Then it'd be x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0. And then you'll start the 2 off. You'll start the 2 off in the opposite direction. You'll start the 2 off to the 0 power, and then 2 to the 1st on the 2nd term, 2 to the 2nd on the 3rd term, 2 to the 3rd, and then finally on the last term, 2 to the 4th. So once you have those coefficients spaced out, the x is put in, the number here 2 put in, you're going to check the exponents. Make sure those pairs of exponents each add up to that main exponent of 4, and they do. Each pair of exponents adds up to 4. So now all we have to do is clean this up. We got 1 out front. We don't need that. You can drop that off, and then also 2 to the 0, you can drop that off because 2 to the 0 power is 1. So that first term is just going to be x to the 4th. For the second term, you have 4x to the 3rd times 2 to the 1st. Well, that 2 to the 1st is going to be 2. So that 4x to the 3rd times 2 is 8x to the 3rd. And then we have 6x squared times 2 squared. Well, that 2 squared, if you evaluate that exponent, that is 4. So it'd be 6x squared times 4. We'll get to that in a little bit. And then 4x to the 1st. We don't need to write x to the 1st, just x is fine. Times 2 to the 3rd. That'd be 4x times 8, because 2 to the 3rd is 8. And then finally on the end, we don't need that 1. We don't need x to the 0 because that's 1 as well. But 2 to the 4th, that is 16. So all we have to do is multiply in a couple places here and we're all done. Multiply 6x squared by 4, that is 24x squared. And 4x times 8, that is 32x. So that is the final product. X to the 4th plus 8x to the 3rd plus 24x squared plus 32x plus 16. That is the expansion of x plus 2 to the 4th power. So if you're taking x minus 4 times x minus 4, you could use the FOIL method or distributive property there. X times x, that's going to be x squared. And x times negative 4, it's negative 4x. Then distribute the negative 4 through that second set of parentheses. Negative 4 times x, and then negative 4 times negative 4 would be positive 16. Simplify that, combine the like terms, negative 4x and negative 4x, that makes negative 8x. But we'll just prove that Pascal's triangle will work on something as simple as that. So you're taking x minus 4 to the second power. So you go to row 2, where the exponent is 2, the coefficients would be 1, 2, and 1. And you might wonder, well, the coefficients there aren't 1, 2, and 1. What's going on? Well, remember, the second term of that binomial is negative 4. So to expand that out, space out your coefficients 1, 2, and 1. And then start with the x to the second power, and then work your way down to x to the 0 power. Then you would start the negative 4, the second term of that binomial. Start negative 4 off to the 0 power, take the sign with it, negative 4 to the first, and then negative 4 to the second. So include that sign in front of that 4. So it'd be x squared out front because you don't need that 1 and you don't need negative 4 to the 0. That's just 1. So it's x squared is the first term. The second term there, negative 4 to the first power, that would be negative 4. If you multiply that by 2, that's negative 8. So that would be negative 8x for the second term. And then the last term, if you square negative 4, that's 16. We don't need the 1. We don't need x to the 0. Those are both 1. That's just going to be 16 for the last term. So x squared minus 8x plus 16, same as what we got up there. Whether you use FOIL method distributive property or use Pascal's triangle, you will get the same answer. We're going to expand x minus 3 to the 5th power using Pascal's triangle. So we want to go to row 5 for our coefficients. The coefficients on row 5, meaning the exponent is 5, would be 1, 5, 10, 10, 5, and 1. So on your paper, you'll space those coefficients out, give enough room so that you get the x and the negative 3 in as well. So space out those coefficients, and then you're going to start the x off to the 5th power. So start the x off to the 5th power, then x to the 4th, x to the 3rd, and you work your way down to x to the 0 on that last term. Then start the negative 3 off, the negative sign and the 3, start the negative 3 off to the 0 power, and then you work your way up to negative 3 to the 5th. A quick check your exponents. Make sure each pair of exponents on the term add up to that main exponent of 5, which they do. Then you just go through and clean this up. You don't need the 1 out in front. You can drop that off. Also, negative 3 to the 0 power, that's just going to be 1. So that first term is going to be x to the 5th. For the second term, you take negative 3 to the first power. That would be negative 3. If you multiply that by 5, it's going to be negative 15. So clean this up. Drop off anything you don't need. Evaluate the exponents. The third term here, negative 3 to the second power would be 9. If you multiply that by 10, that's going to be 90 x to the 3rd. For this term, negative 3 to the 3rd would be negative 27. If you multiply that by 10, that's negative 270 x squared for that term. And then the next term, negative 3 to the 4th would be positive 81. If you multiply that by 5, that's going to be positive 405 times x. And then finally, you don't need the 1. You don't need x to the 0. Those are both 1. You're looking at negative 3 to the 5th power on the end. That is going to be negative 243. So there it is, the final product. X to the 5th minus 15x to the 4th plus 90x to the 3rd minus 270x squared plus 405x minus 243. A lot easier using Pascal's triangle than it would be to multiply that out manually. X minus 3 multiplied by itself 5 times. I'd choose to use Pascal's triangle.